So in our previous class, we have basically discussed about aggregates, some of the aggregate properties. Okay, and what are the basic properties, what are the sources of aggregates, and what are the different types of aggregates. So in this class, we basically will discuss about the characterizations of the aggregate, that is how an aggregate can be characterized. So before starting this, in this chapter, we have some new concepts. Let us discuss this concept. Now, as stone aggregates are also called it is as granular materials when not bound by any cementing material show strength only under confinement. Now the thing is, what is confinement? Confinement means when that stone aggregates are kept in a container. Okay, in a confinement in a container. In that case only it will exhibit some of the strength, because in that case all these aggregate particles will be along with each other. In that case only it will show some strength. Otherwise, that all these aggregate particles will be separated from each other, and there will be no strength of the aggregate when stresses are applied to it. Now, this relationship between the resilient modulus, MRV you know, that is resilient modulus, and this resilient modulus, as per the definition, was diametric stress divided by recoverable strain, which we have already discussed in our previous classes. Now, this confining pressure sigma 3 for the granular material may be put 4 pressure. That is your formula. Now, what was the confining pressure? So, MR value was found out from dynamic triaxial test, and in the dynamic triaxial test, in the triaxial cell, that water pressure around the soil cell or that portion of the cell is basically called confining pressure, or sigma 3, or in other words, minor principal stress. So this MR value can be equal or can be proportional. It is proportional to your confining pressure. Okay, and that relationship can be established as MR value equal to K1 into confining pressure to the power K2. Now, this K1 and K2 are material constant. Now, how to find out that material constant? You will go for extensive testing for different materials to find out what are the K1 and K2 values. Now, for example, this K1 and K2 values are found to be 3.18 and 0.73 respectively for granular soil with non-plastic pillar, and that sample was collected from NH6. So basically that is an example that how this K1 and K2 value should look like. Now this is one formula. Now another alternative formula for the MR value is MR equal to K1 into theta to the power K2. Now K1 is the K1 and K2 are the material constant, and here another term is used, that is theta. And what is theta? Theta is the first stress invariant in a stress component of a dynamic triaxial test. Now, what is stress invariant? Stress invariant is a particular combination of stresses which remain unchanged when you change the coordinate systems. Okay, so stress invariants are certain combination of stress components which remain unchanged irrespective of the choice of the coordinate system. Now, how this combination of the stresses works? So basically, if you consider about a three-dimensional soil particles, okay, suppose a soil particles is there and stresses are acting upon that soil in each and every side. Okay, in a three-dimensional way, if you consider this, in that case, that stresses imposed on that particular material can be expressed by a matrix form. Okay, now in the matrix form, you know that the diagonal matrix, the diagonal portion of the matrix remain unchanged if you transpose this or do other forms. So in that case, the diagonal portion is basically that your first stress invariant. So basically this model, whatever model is suggested over here, this model is called your K theta model. And there are different types of model which has been prescribed to find out what are the MR values and what are the K values. So basically that are the characterizations of the aggregate. Now these equations, whatever equations we have discussed, that equations and whatever other equations are there, that all these equations are basically stress dependent, and the type of these equations are non-linear. They are not linearly related, they are non-linear with that MR value. That is, MR value and stress are related with a non-linear equation. Now its implication could be understood in the following way. So a granular layer with a pavement is thought of where the MR values of individual elements are assumed to be equal to some physical unison. So whenever you are going to analyze that MR value, okay, going to analyze that MR value and characterization of that granular material in a pavement layer, in that case, initially you will assume that MR value throughout the layer is equal or same. Now then you will go for the trial and error method using finite element method or any other types of method. So initially the analysis of the pavement structure would show that stresses and various elements are different depending on their location with respect to the load point. Okay. Suppose one load point is there. Suppose this is the load point, okay, and these are the different granular methods. So based on their distance, it is found that their MR values is also changing, okay, and other properties is also changing, and it depends on their location with respect to the load point. So with the changes of the location, their stresses at various locations also changes. Now by using any of the equations, whatever equation we have discussed, or if any other equation is there, using that equation, a new set of MR values of the individual elements are obtained, which will be found to be different from each other. Okay, so initially what you have assumed, initially you have assumed that MR value throughout the material will be similar, but after that when you apply the load, you will found using that equation that MR values are changing. Then you will again get a new set of MR values. So similarly, you will again do the similar steps and found out that another new set of MR values. So this analysis is repeated and a different set of stress values other than the earlier analysis is obtained. So this forms an iterative procedure. Iterative procedure means trial and error procedure. Therefore, some finite element method, I don't know whether, I think that you are not familiar with this method. Basically, that finite element method is an advanced method. In that case, we will analyze a particle by analyzing the microstructure or micro portions of that element. Now, these are the characterizations of the aggregate particles. So, I think it is clear. If you have any confusion regarding this, you can ask me. So these are the characterizations. Now another type of characterization. So you are characterizing the aggregate using the MR values. Now there are other type of characterizations of the aggregate based on the different parameters. Based on the parameters like their strength, hardness, toughness. Okay, so there are other parameters also. Now this strength, the aggregate should be sufficiently strong so that they can bear the traffic load without getting crushed. And the name of the equipment used for the measure of aggregate strength is known as crushing strength test, which you have already did your testing in the lab. Then hardness parameter is basically the resistance to continuous of wear and tear of the wheels of the vehicles on the road surface. Now, this hardness parameter of the aggregate is tested using Los Angeles test or Devil's abrasion test, and there are other tests which is Polish stone test. So these are the tests where we can test the hardness of the particular aggregate material. Then toughness is resistance to the weathering action. Now, toughness of a material is its ability to sustain impact loading and weathering action. The aggregates on an in-surface road, the toughness characteristics is checked using the impact value test. Then durability. So durability is the gradual deterioration of the aggregate takes place as is continuously exposed to the environment. So this aspect called the durability of the aggregate, and it is tested with soundness test. So in this test, there are different chemical particles which is mixed with the aggregate, and after that it is checked whether that aggregate particles is deteriorated or not. And if deteriorated, in that case, how much percentage of the aggregates are deteriorated. So that is your soundness test. Then shape test. There are two types of shape test: flakiness index test and elongation index test. Whether flakiness or flaky particles are that particles whose least dimension is less than 0.6 times of their mean dimension, and your elongated particles are those particles whose greatest dimension is greater than 1.8 times of their mean dimension. Then water absorption test. Now this water absorption test determines the tendency of the aggregate to absorb water. Now the thing is, if a aggregate particles absorb more water, in that case what will happen? So for the bituminous concrete road, then in that case it would have a little effect, but for the cement concrete road, it have a devastating effect. So initially, what will happen? Suppose you are mixing your aggregate with your water, adequate quantity of the water, cement, sand, etc. Now that water content used for that mixing would be equal to your water cement ratio. So based on your water cement ratio, you have mixed water with the aggregate particles. Now the thing is that if the aggregate absorb excess quantity of water, in that case it will absorb the water from that water cement ratio, that water you have mixed for the mixed proportion. So in that way, the water required for the mix would be getting lower. Okay, so for that reason, it will affect the workability of the aggregate particles or workability of the concrete particles. Then another test is adhesion with the bitumen. Adhesion with the bitumen means you need to check whether the aggregate particles are mixed with the bitumen particles properly or not. Okay, so how it will check? So when aggregates are mixed with the bitumen, a thin film of bitumen is formed over the aggregate. okay, which helps in holding the whole mass together. So if the aggregates have a relative higher affinity towards the water, bitumen is sometimes stripped off. Stripped off means washed off from the aggregates, leading to failure of the bituminous mixes. So therefore, adhesion with the bitumen is tested with a type of test which is called stripping heavy test of the aggregate particles. Now let us discuss in details about the different type of test for the aggregates. So in this class we will discuss about the crushing strength and abrasion test of the aggregate material. So crushing strength test is used for to know the strength of the aggregate particles, and abrasion test is conducted to know the your hardness of the aggregate particles. So this crushing strength test we have already performed this in our lab. So basically in this crushing strength test, a total load of 40 tons is applied at certain rate. That rate is 4 tons per minute. I think you have remembered in our lab, whatever testing equipment is there, in there load reading was in kilonewtons. So you have to convert that 40 tons load into kilonewtons, and you have to find out what is the total load in kilonewtons. Okay, now for this test, basically aggregate passing through 12.5 mm and retained on 10 mm is required, and you have to put that aggregate in a special container in 3 layers and tamping each layer with 25 numbers of rows. And after that crushing strength test, you have to see that aggregate particles through 2.36 mmC, and the percentage weight value passing through 2.36 mmC with reference to the total weight of the aggregate gives a measure of your aggregate crushing strength. Now this mean of the two such results rounded off the nearest whole number gives the aggregate crushing strength. Okay, suppose for one test that is 5.7% or 10.5%, and for another test it is suppose 12.5%. In that case, you will find out the average value and rounded it off. Then that value will give you the crushing strength of the aggregate. Now, there is one check. The 10% fines test is an iterative test used to find the load required to achieve a crushing strength of 10%. So basically that is the new portion. So there is some variations of the test. So that is called the 10% fine test. Okay, so basically 10% fine test is an iterative test that is a similar type of your crushing strength, But here you will go for the trial and error method to find out what is exactly that total load would be if you want to get a total fines of 10%. So that's why it is called 10% fine test. So as per the provisions of the code, the 10% fine test is recommended for the material whose crushing strength value is 30 or above. Okay, so here for the general material, we will go for the crushing strength test. Now, if you found that your crushing strength test is more than 30%, in that case, you can have that 10% fineness or 10% fines test. I think it is clear. So I think it is clear. Let us discuss about the abrasion test. So you know about that abrasion test. So in our lab, whatever abrasion testing was there, that test is basically your Devil's abrasion test. So basically in the Devil abrasion test, there are two containers in which in that two container you have to put your aggregate depending on the different gradation size, and along with that aggregate you put some steel balls which is called abrasive charges. Now after that, that portion will be rolled over, that container will be rolled over, and if it is rolled over, in that case there would be contact and or abrasion between that aggregate particles and steel balls. So that's for that reason that aggregate particles will get polished and some dust particles will be formed there. Now, after that, to a required number of the revolutions, you will see that aggregate with 1.76 mm IS6, 1.7 mm IS6, and we'll find out what is the percentage fine in terms of total weight of the aggregate. So in the abrasion test, there are three types of test. One is Los Angeles abrasion test. So in the Los Angeles abrasion test, there is only one cylinder and a cylindrical container of 500 width and 700 diameter. So basically that is a larger one than your devil's container, and it rotates at a rate of 20 to 33 rpm along its axis for 500 to 1000 times, depending on the aggregate gradation. There are different aggregate gradations, so depending on the aggregate gradation, it will revolve with a rate of 20 to 33 rpm. So generally, as per measure, 5 to 10 kg of the aggregate, that also depending on the different gradations of the particles, is put inside the cylinder. So basically, that is your Los Angeles abrasion test. Okay, so these are the portions you put your aggregate through this hole, and after that, it will start revolving. So specified number of steel balls, and that specified number of steel balls is also depending on the gradation of the aggregate, each of 48 diameter and varying weight of 390 to 445 grams. Their weights are put as a abrasive charges into the rotating cylinder. Now when the test is over, then aggregates are collected, and aggregates are sifted through 1.7 ice sieve and washed and dried in an oven at 105 to 1110 degrees Celsius. Now difference in the weights expressed as a percentage of the original weight is the Los Angeles separation level. So first initially what is your weight of the aggregate, and after the conducting of the test, what is the weight of the aggregate. So basically you are finding out what is the total loss of the weight, that is what is the total final particles, okay, which passes to 1.7 sieve divided by your total weight of the aggregate into 100%. That is your Los Angeles abrasion test. Let me share you, see you how this test is conducted. I'll go directly to the, see there is the deliberation. So this is all in today's class. Now I am taking the attendance. After that, you can leave. Okay, you can leave now.